Have you ever wondered how algorithms work behind the scenes? It can be fascinating, yet confusing. If you're curious about the math behind finding the optimal integer in a sorted array, you're in the right place. Today, we're diving into the algorithm that minimizes absolute values. I totally get it. Trying to understand algorithms can feel like deciphering a secret code. You're not alone in this struggle. Many people find themselves puzzled when it comes to the math behind algorithms, especially when it involves absolute values. Here's the specific question we're tackling today. One user asked, "How do I find an integer x in a sorted array that minimizes the sum of absolute differences?" They provided an example with the array 2, 4, 7 and found that the optimal x is 4. Sound familiar? Let's break this down together. So why does this work? The key lies in understanding how absolute values behave in a sorted array. The median of the array minimizes the sum of absolute differences. We'll explore this concept step by step to clarify how we arrive at the solution. And stick around. At the end, I have a simple explanation that will make this concept crystal clear, plus a bonus tip on how to apply this in real-world scenarios. To understand why the function works, let's first look at the problem. The user needs to minimize the sum of absolute differences between a sorted array and a chosen integer x. The key insight is that the optimal value of x is the median of the sorted array. This is because the median minimizes the sum of absolute deviations. In a sorted array, if the length is odd, the median is the middle element. If the length is even, the median is the average of the two middle elements. However, since we want the smallest integer, we take the lower middle. Now let's look at the function provided. It calculates the median by accessing the element at the index of half the length of the array, adjusted for zero-based indexing. In conclusion, the user can see that the function efficiently finds the optimal integer x by leveraging the properties of the median in a sorted array. Let's look at the code you provided. The function takes an array A and returns the element at the index calculated by taking the ceiling of half the length of the array minus 1. This effectively gives us the median for both odd and even lengths. Fun fact, the concept of absolute values is so fundamental that it appears in various fields from physics to economics. It's like the Swiss Army knife of mathematics. Now let's look at the answers provided by other users. This user presents an alternative solution for finding the integer x in a sorted array. They suggest using the middle index to determine the optimal value. For an even length array, the solution will always be to the left of the middle, while for an odd length array, it will be the middle item itself. The user explains that using math.ceil on half the length of the array helps find the correct index. This approach minimizes the sum of absolute differences, as subtracting the middle item yields the lowest total. Let's take a moment to review another user's answer. This user presents an alternative approach to finding the optimal integer x. They explain that if we have values where I minus x is negative and others where it's positive, adjusting x affects the total sum of absolute values. Increasing x raises the sum by the difference between the counts of negative and positive values. Conversely, decreasing x lowers the sum. The goal is to balance these counts, achieving the minimum when they are equal. Let's take a look at an answer from another user. This user provides an alternative solution by focusing on the mathematical properties of the problem. They explain that the goal is to minimize the sum of absolute differences from a chosen integer x. By factoring out the number of elements, they show that the first term relates to the average of the list. They conclude that the optimal value for x is the median of the sorted array, which can be found using the formula math.ceil, a length divided by 2 minus 1. Here's the bonus tip. Understanding the median can help you in data analysis and statistics. It's a powerful tool that can simplify complex problems. Keep this in mind as you tackle future challenges. And there you have it. You've learned how to find the optimal integer in a sorted array using the concept of the median. Remember, mastering these concepts will make you a better problem solver. If you found this helpful, hit that subscribe button for more insights.